Good day, everyone. This is our water resources presentation. Sorry. Our group members are as follows: Akili Phillips, myself, Ian Dixon, Gavin Rogers, Nathan Treasure, Ravina McLeod, Kenada Matheson, and Romain Arjun. The objective for this project is to provide background information on the area of focus. Afterwards, we take a look into the present conditions of our area, solutions to the problem, the hydrology of the area, inlet and channel type, and then finally look into the canal route and inlet location.
Okay, so for this project, we decided to review and investigate the Marcus Garvey Drive Road. In March 2016, contractors and the government of Jamaica decided that they would renovate the Garvey Drive roadway. They spent 20.5 million Jamaican dollars to execute the improvement. However, in 2020, the island had extreme rainfall during the hurricane season, which caused the roadway to experience major flooding. In January 1970, Marcus Garvey Drive, formerly called Shore Road, was created due to the destruction of the Portmore Causeway. The engineers decided that to construct such a roadway properly, it couldn't just end right there. In fact, it needed to be extended. And that is how they decided to construct the Marcus Garvey Drive Road. Also, the companies that inhabited that side of the island, such as Petrodram, formerly known as Esso Kingston Refinery, before it was bought by the government, thought it was a good idea because they needed a road and a new area for business. Due to Jamaica having one of the highest water tables in the Caribbean, when the land was dumped to create Marcus Garvey Drive, it was dumped with granular soil and foam. The drainage system that is in place directs the water into the soil. Now, seeing that Jamaica already has a high water table, when they direct the water back into the soil that is already waterlogged and oversaturated and it wasn't dumped properly, it's one of the main reasons for flooding in the area.
Okay, so to gain a better understanding of the situation at hand, the group members had decided to conduct a site visit to understand the extent and better be able to develop solutions for the problem. So, on the side of the road that is leading towards the downtown area, upon investigation, numerous problems were seen with the drainage system that currently exists. Problems seen included insufficient drain size, inlet clogging, polluted and blocked drains, and inadequate outlet streams. So we're going to look at some images that we took when we did this on-site investigation. So on the left-hand side, we can see an inlet here that is clogged with small pebbles and stones. This hinders the outflow of the storm water and cause a backup of drainage. On the right-hand side here, we can see a picture. There is actually an inlet here as well, but it's covered with dirt, and we can see vegetation growing on it as well. So this highlights the need for maintenance for these inlets. Alright, so on the left hand side we can see an outlet here on the side of Marcus Garvey Drive. We can see a lot of vegetation. This indicates a severe lack of maintenance, so this needs to be cleaned up because it hinders the flow of the stormwater. On the right hand side here we can see a small outlet here. It's very narrow, so the volume of stormwater that flows through it can't handle that amount of capacity, and we can see that it's still being backed up because of pollution. Alright, so this is the outlet which the stormwater from Marcus Garvey Drive flows into. So on the top left hand side, you can see a lot of vegetation growing on and on the sides of the canal here. This holds the water in place and prevents flow, so the stormwater just backs up. On the lower right hand side, you can see a lot of pollution, which adds to the backing up of the stormwater, so this needs to be maintained and cleaned up. Right, so on the left hand side, you can see where the outlet meets the drainage here, and the water level is the same. This is a problem because there is no difference here, which will allow the flow, the outward flow of the stormwater, and there's also vegetation. On the right hand side, we can see a whole fridge in the canal here with a lot of plastics and garbage backing it up, preventing the water from flowing. Alright, so here we have a major issue with the size. This size can't accommodate the amount of volume of stormwater flowing through it. It is about 2 feet, and that's not enough, so a solution is needed to put in place for this part of the drainage system. Alright, so here is on the side of Marcus Garvey Drive. You can see that if there's heavy rainfall and the road is flooded with the storm water, the water has nowhere to go because the drainage system runs below the sidewalk. So it just flows over onto the side and into parking lots and just cause a backing up and flooding. Yeah. So here you can see there is severe pollution going on, a lot of vegetation growing. There's little to no maintenance evident here, so there needs to be a solution for this as well. Alright, so here shows a small, you can call it a pathway for the stormwater to take. This can handle any amount of large volume of rainfall, so it just overflows and goes on the other side of the road. So the purpose of this is not really it's not meeting the amount of stormwater that's needed, that is designed for. So there's a close-up of one of the inlets on the sidewalk here, and you can see where the stormwater is supposed to flow out towards onto the side here. Alright, so this is a strip of vegetation where a lot of frequent flooding happens. A lot of the water is held here when there's heavy rainfall. There needs to be a solution for this as well, because this adds to the severe flooding on Marcus Garvey Drive.
Okay, so some solutions. The first solution identified could be to have existing inlets cleaned and possibly updated to handle larger volumes of water. More inlets along the road could also be beneficial to catch more water and transport it to open drain. Another solution is to install an inlet at the bus stop in which it is prone to flooding. This can channel the stormwater into the groundwater drain. Widening the existing drains near the area that is prone to flooding is also another plausible solution, as it would be possible to carry more water away to the gullies, thus preventing any large volumes of water remaining on the road. For these solutions to work, it is seen that these drains would have to be inspected at least twice a year to ensure there is no cloggage with any waste material that will ultimately prevent stormwater flow. Cleaning the drains and removing the pollutants and water products would also be another solution, as this will clear the drain for water and apologies, as this will clear the water in the drain and allow for more free fluid flow. The outlet stream would also need to be updated so that the stormwater coming from the drains are not at the same level as the outlet water.
Okay, so an alternative solution would be a flood tunnel. Now, the idea of a flood tunnel basically is an area under a surface, hence tunnel, that are filled with columns weighing tons, right? So the idea of this flood tunnel would be, for Marcus Garvey Drive, would be the area that is inhabited by Tinsipen heirloom. It could be the government of Jamaica would have to petition for a piece of their land so that they could rise the road that leads to Marcus Garvey Road, but starts at Causeway. Now, it's as I said, it's an idea because the dimension of the tunnel would have to be a little less than the criteria for landing of planes because the Tinsipen Airdrome is right there. Also, when the area is when the area is raised by the tunnel, that's where we would pump all the water so that it could freely flow back into the ocean where it belongs. Now, the flood tunnel that is located in Tokyo is about 30 years old, and during that time, the budget for such a plan was 2 billion US dollars. Now, if Jamaica had done that for a road that's almost 50 years old, we would still be seeing results.
Okay, so now for the hydrology. When we speak about hydrology, we're basically talking about the area around our area of focus, or the environment around our area of focus. So now, given that our area of focus is a part of Marcus Garvey Highway, or Marcus Garvey Drive, sorry, we would notice that to the left we have Kingston Wharf, which consists of paved grounds, and to the right we have the airfield, which consists of grass grounds. Now, another factor about hydrology is the catchment area. Now, the catchment area is basically each area of the environment that contributes water to our area of focus. Now, given that our area of focus is Marcus Garvey Drive, for example, let's say that in a rainy season, water comes from Kingston Wharf, sorry, as well as the airfield. Now, we would have to do a rough estimation to get basically just an idea of how much water would be coming from each area. So now we'd use that and sum it up to add our total catchment area, which all would contribute water to our area of focus. So based off of analysis, we notice that our area of focus, or our catchment area, consists of our area of focus and part of the highway that is coming from Portmore. Kingston Wharf and the airfield do not necessarily add any form of water to the Marcus Garvey Drive road due to the elevations and slopes that exist. So here we have a 24-hour extreme rainfall map for a 10-year return period. Now, you can't exactly see the values, but there is a value beside each black dot. Now, in the area that we're focusing on, which is around right here, the value that we get is 180.6 millimeters of rainfall. Now, using this value, we're going to use this table where we have a 10-year return period, and we're going to be using a duration of 10 minutes. So using the table, we get a ratio of 0.4. Now, using this 0.4 value, as well as the 180.6, we're going to put into this equation at the bottom to find the rainfall intensity, which will be later used in our hydraulic calculations.
Now, in the selection of an inlet, many factors have to be considered. So factors such as maintenance, efficiency, and the inlet's capacity are integral in this selection process. The capacity of the inlet is dependent on the roughness, the gutter longitude slope, the total gutter flow, the inlet configuration. So the efficiency of an inlet is the percent of total flow that the inlet will intercept under a given set of conditions, according to Johnson and Chang in 1984. The efficiency is dependent on the cross slope, the longitudinal slope, the interception capacity, the total gutter flow, and the minimally a pavement slope. So therefore, after careful and extensive analysis, the inlet that was selected was the curb opening inlet. So a curb opening inlet, according to the Stormwater Studio, is a vertical opening in the curb covered by a top slope. So to your right is a visual representation of a curb opening inlet, and these inlets are effective at locations where the flow at the curb is sufficient for the inlet to perform efficiently. They are relatively free of clogging and offer little interference to traffic. We also should know that curb opening inlets do not function well on steep slopes because of the difficulty of directing flow into the inlet. And since Marcus Garvey Drive is not on a slope, a curb opening inlet will suffice. So to your left here is a visual representation of the curb opening inlet, and we should note that a curb opening inlet, as I said, it doesn't clog easily and it's bicycle safe, and it reduces maintenance that the inlet with grades carry. Now, as engineers, we are going to make up during our analysis, we're going to conclude our specifications. So for our curb opening inlet, the length, we have at 7 feet. KT, which is a constant, we have at 0.6. The gutter flow, we have as 2.97. The gutter slope, we have at 0.015. Manning's value, we have at 0.016. The cross slope of pavement, we have at 0.35. The depression over the gutter width, we have at 0.75. And the ratio of flow in the gutter section, we have at 0.084. Now, to calculate LT, which is the curb opening length, we need to calculate first SC to sub it into LT. So we use that formula and we got 0.098 for SC. And now subbing SC into the LT formula, we got a curb opening length of 12.95 feet. Now, if the specified inlet is larger than LT, it will capture 100% of the flow, and Q capture will equal to Q. But if the specified inlet is less than the captured LT, then Q capture is computed as the following. And since we got the 12, and the 12 is greater than the 7, we have to calculate the efficiency of our curb opening inlet, because it's not 100%. So calculating the efficiency of our curb opening inlet, we got an efficiency of 75.3%. And now calculating the Q captured, we use the efficiency times the gutter flow, and we got the Q captured as 2.236 cubic feet per second.
So for the channel type, for this project, based on the solutions that were stated earlier, it would be seen that the solutions for this problem would both include open and closed channels. The open drains will both be comprised of concrete for the closed drain that will run underground, and we concluded that HDPE, which is high density polyethylene pipes, will be used also. In the next slide, we showed how the pipes will look and how they will be laid. Also, for the pipes, they will be about 2 feet in length.
Alright, so for the canal route, in this image, you see that there is a highlighted square. Okay, so this is where the underground pipes would go onto the next side of the road to the existing drain. So we'll be connecting the two drains, the underground drain or the closed drain to the open drain. But in this case, our open drain would be greatly updated and improved to hold a larger volume of water. Now, the reason why we did this solution was due to the distance between our area of focus and the gully that exists. So this area right here shows the gully, or the existing gully, that the water is transported to. And this is our area of focus. Now, it can be seen that on the side of the road that is going towards downtown, there is an existing drain that is present. So we will be taking advantage of this existing drain to transport the water effectively and efficiently.
So the inlet location, you'll have a total of 8 inlets that will be installed on the lane going from downtown to Portmore. 4 of those inlets will be installed in the grass area that is in the vicinity of the overhead bridge, and the other 4 of those inlets will be installed further down along the road in between the post office and wharf, going from coming from downtown. The purpose of installing these inlets will be to channel the stormwater off the road, and the inlet spacing should be no less than 400 feet apart from each other. We'll be using manholes along the channels for the purpose of inspection, cleaning, and to change the direction of the channels. So manholes are small covered openings in a paved area that allow for access beneath, especially ones leading to sewer or stormwater. Manholes allow for cleaning, inspection, connections, and repairs. There are three different types of manholes. You have the shallow manhole, the normal manhole, and the deep manhole. The shallow manhole is from 2 to 3 feet deep, and that is just for the purpose of an inspection. The normal manhole is from 3 to 5 feet deep, and it is equipped with a step ladder, and this is used for inspection, for cleaning, and for repairs. And the deep manhole, which is 5 feet or more, has the same purpose, and this has a ladder attached to it. And the deep manhole and the normal manhole is equipped with a heavy-duty manhole cover. Due to the fact that we'll be using inlets that have no grating coverage, we'll be using our manholes for the purpose of cleaning out any debris and blockages that are present in the channel line. For the purpose of our project, we'll either be using a normal manhole or a deep manhole, because we'll be needing the manhole to be big enough for persons to walk through so that they can check the channel lines and make sure that everything is cleaned. And the manhole spacing will be anywhere between 300 to 500 feet apart.
So, in conclusion, background information on the road was provided, the current condition of the area of focus was discussed, possible solutions to mitigate the problem were shown, the hydrology of the area, the inlet type, channel type, canal route, and inlet location were all stated and explained. This is a slide showing our references used, and this is now the end of our presentation, and we thank you for your time for listening to us. At this time, we take any questions.